And there aren't like a ton of us. So unmute yourself and ask questions as we're going along. I don't just want to choke through content and then feel like you don't have the chance to interact with it. So I just want to make sure that, you know, I'm doing the best I can to answer ideas or concepts that you are just like, what the heck are you talking about? And make sure that they're clear for you. So what I did last week was go back and re-record myself doing the algebra lesson and sent that out. So instead, what I'm going to do, obviously we're recording this today, and then that way you can have this to replay. If there's a part or a concept or a question or a type of problem that you're like, oh, let me go back through that, you can replay the Zoom meeting so you can have that. So what I'm doing right now, obviously, is sharing my screen like I did last week. I have my little TwidLab pad up here to be able to work through problems. And I just wanted to go back through and remind you of the formulas that are given on the SAT. And these are all geometry formulas. And in fact, what we're going to do next week is talk about geometry and talk about more of the advanced math facts and sort of how they build into it. So that's sort of our last lesson for the week. And then looking at the additional formulas today, I just want to zero in on a few that we're going to talk about. In the top right corner, we have percent times the whole equals the part. Percent increase and decrease is equal to a difference divided by the original. So we'll talk about percent change. I also threw in distance equals rate times time because I feel like those word work problems from you know, back in the day, like middle school math, they come back here. Of course, then we also have down in the bottom left, exponential growth and decay, and we'll talk about how to approach those as well. The remaining formulas, all the stuff about triangles, unit circle, length of an arc, area of a sector, and completing the square, we'll deal with in our last lesson next week. So, okay, so without further ado, let's take a look at unit conversion. And I started with just a couple of problems that I selected from across a number of tests. Now, by the way, last week's lesson, I pulled all of those algebra problems out of tests 1, 2, 3, and 4, which you can find online, and I can, of course, send them to you. The problems I'm pulling today are from tests 1, 2, 3, 4, 5, 6, 7, 8. So what does that mean? That means that there are fewer of these problems on a test, and the problems are a little bit far, you know, few and far between exams. So I had to go to kind of compile all of these, go across a number of tests. I didn't dig into tests 9 and 10, which are the October 2017, 2018 tests. I didn't dig into the April retired tests, May retired tests, or any of those, or the March retired tests. So know that there are like many more tests than the ones I'm mentioning, but this is where I pulled the problems from. So if they seem familiar because maybe you've practiced some of those tests before, then there you go. Okay, so what I'd like to do is just talk a little bit about unit conversion and sort of how they can present these problems to you. So looking at number 6, they're talking about the metric system. They may also do unit conversion using our standard system, so inches, feet, yards. They may also talk about gallons and quarts. They may make up some things. They made up one here in number 33. Well, it's coming from Roman times, the pes. So they may use other concepts to make some sort of proportional change, okay? All right, so looking at question number 6, a hospital stores one type of medicine in 2 decagram containers. Based on the information given in the box above, how many 1 milligram doses are there in one 2 decagram container? Okay, so here what we're going to do is 1 decagram equals 10 grams. And then I would take this next one and actually flip it. 1 gram equals 1,000 milligrams. And then what I would do is unit convert everything. So we have 10 grams is to 10 grams. So I'd multiply the second set by 10 for both terms. So then you'd have 1 decagram. I'm going to make it lowercase d so it doesn't look like 10, is to 10 grams. 10 grams is to 10,000 milligrams. Okay, great. Now they want you to have 2 decagrams. So then what we would do is multiply everything by 2, and that would be our unit conversion. So 2 decagrams is to 20 grams is to 20,000 milligrams. So that would be my answer. So it could be pretty simple, like number 6. Number 6 was a math no calculator problem. So sometimes it'll come in that form, pretty simple. Number 19 is math with a calculator. So if you have your calculator, feel free to use it. And so it's a medium problem. It's the end of the medium problems. And we're going to have to do a couple of steps of unit conversion here. So graphene, which is used in the manufacture of integrated circuits, is so thin that a sheet weighing 1 ounce, can cover up to 7 football fields. So 7 football fields. So you see here, it's not ounces is to pounds or something like that straight off the bat. They're comparing like what it can cover. And here they're giving you the example of football fields. And what they're also saying is that 1 football field is approximately 1 1/3 acres. So I'm just going to slide this over just a little bit so I have a little more room. So 1 1/3 acres. And then they're saying, well, how many acres could 48 ounces of graphene cover? All right, so my very first instinct is to convert your 7 football fields into the number of acres that would include. So I would do 1 1/3 times 7, and that means that 1 ounce can cover 9 1/3 acres, if everybody's okay with that. And they want to know, well, what does 48 ounces cover? So if you're noticing here, this is a proportion now that we've done our first unit conversion, right? So 1 ounce is to 9 1/3 acres, as 48 ounces is to X acres. So then we can cross multiply and divide, and 48 times 9 1/3 is 448 acres. If you divide that by 1, it's going to remain the same. So what's your best approximation? 450 acres, which is our option here. When I send this along later, I'll include the answer choices as well. Okay, and then number 33, the pes, a Roman measure of length, is approximately equal to 11.65 inches. It is also equivalent to 16 smaller Roman units called digits. Based on these relationships, 75 Roman digits is equivalent to how many feet to the nearest hundredth? Okay, so let me clear out my board here. Okay, so we have 2 different types of unit conversions that need to happen. And notice that this is number 33, so that means that it's math with a calculator in the open-ended section. And it's 31, 32, 33, they're on the easier side, but 33 is getting closer to a medium type problem. Okay, so the PES is 11.65 inches, and it's equivalent to 16 digits. Based on the relationship, 75 Roman digits is equivalent to feet. So 75 digits, let's start off by answering how many inches that would be, and then we'll go and convert into feet. Okay, so 75 times 11.65 is 873.75. So 873.75. And then so you cross multiply and then divide. So then we would divide that by 16. So that would be 54.61 inches. but they would like the answer in feet. And I'm always inclined to circle what I'm looking for and make sure that I'm not just immediately writing down my answer for inches, that I would then go and divide by 12, which would get me feet. So it would be 4.55 feet. And they said to the nearest hundredth. So I took that out to my second decimal point. So there we are. So those are 3 examples of the unit conversion that you're going to see here. The next thing is that obviously builds into ratios and proportions. Once you've done your unit conversion, they're usually asking you for another step, which is, hey, make this bigger, make this smaller, make this into a different, different unit. So what I did here was create a slice of a number of different ratios and proportions that you may see on the test. Sometimes it's just looking at a table and interpreting it and trying to find out the straight proportion. Sometimes you have to do a little bit more with this unit conversion or proportion. Sometimes we have to interpret some sort of chart and then go further with it. So I just thought I'd show you a couple of those. And then I did some more here that are a little bit more, a couple that are a little bit more advanced. Okay, so let's start with 21 as an example. It's going to make it bigger so we can look at that one and the board. Okay, so the data in the table above were produced by a sleep researcher. Studying the number of dreams people recall when asked to record their dreams for 1 week. Group X consisted of 100 people who observed early bedtimes, and Group Y consisted of 100 people who observed later bedtimes. If a person is chosen at random from those who have recalled at least one dream, what is the probability that the person belonged to Group Y? So they had to recall at least one dream. So that would be 11 and then 68. So it would be 11 plus 68. And then we have to identify what is the denominator. So they're saying here, if a person is chosen at random from those who recalled at least one dream, what is the probability that they belong to Group Y? So these are the Y more than one dreamers. But the denominator has to be greater than one dream. So that would be, the total would be 39 and 125. So 39 plus 125 would be your denominator. So we're going to have 79, and that's going to be out of 164. Yeah. So that's your proportion. So that's just pulling that out of the data. I'm sorry, the ratio out of the data. Okay. If we look here, a quality control manager at a factory selects 7 light bulbs at random for inspection out of every 400 light bulbs produced. At this rate, how many light bulbs will be inspected if the factory produces 20,000 light bulbs? So right away, we're setting up a proportion because we know that they're going to randomly check 7 out of 400. And how many would they select out of 20,000? So again, we set up our proportion, cross multiply and divide. And again, this one is going to be a calculator problem because the terms are quite big. So it would be 350 total here. Okay, Wyatt can husk at least 12 dozen ears of corn per hour and at most 18 dozen ears of corn per hour. Based on this information, what is a possible amount of time in hours that it could take Wyatt to husk 72 dozen ears of corn? So here, this one's just more of a data analysis, but using a little bit of unit ideas, right? So if I would do 72 divided by 12, and then 72 divided by 18, you could figure out your range of how long it would take you to husk all of that. So that would be 6 hours on the low side, and I'm sorry, on the high side, and 4 hours on the low side. So you could say 4, 5, or 6, and all of those would be acceptable. This one is going to be a ratio problem that gets a little bit more advanced. We're going to have to get into our calculator here because we're going to have to find the ratio for the original part of the problem, and then we're going to have to find what answer matches that. So for question number 23, of the following, which program's ratio of its 2007 budget to its 2010 budget is closest to human resources 2007 to 2010? So that means I would put 4,051,050 in the numerator, and then I would put 5,921,379 in the denominator. And you're going to figure out your ratio by dividing that. So 4,051,050 divided by 5,921,379 gets me a decimal of 0.68. So now what we have to do is the same tedious work of taking the 2007 to 2010 numbers for agriculture, natural resources, education, highways and transportation, and public safety, and do the same thing. So I'm going to give you guys a minute to work through that, and then you can tell me what answer is going to be closest to this decimal point here. Any answers? So when I calculated out all the ratios, I found that A is 0.76, B is 0.72, C is 0.82, and D is 0.56. So which one is closest to it? It has to be B. So there you go. Okay, fine. So you can see that the ratios will get more involved or they'll change over time. And I'd like to focus on question number 29 here, because this is going to, the answer is going to be a ratio, but you have to do systems of equations like we did last week in order to be able to get the answer. So I'd like to be able to go through those steps with you because it's going to build on the concept that we did last week. Okay, so here we go. So the incomplete table above summarizes the number of left-handed students and right-handed students by gender for the 8th grade students at Keisel Middle School. There are 5 times as many right-handed female students as there are left-handed female students. So if I were to draw the chart here, just so we can have the data organized, so we have female, we have male, left, right, 18 and 122 as the totals. And there are 5 times as many right-handed female students as there are left-handed students. And then it says there are 9 times as many right-handed male students as there are left-handed students. So I made them X and Y, males and females should be different variables because their totals are going to be different. And then it says if there's a total of 18 left-handed students and 122 right-handed students in the school, which of the following is closest to the probability that a right-handed student selected is female? So it's going to be out of right-handed students, and it's going to be a right-handed female. So ultimately, that is the ratio that we're looking for. But we can't deal with that just without raw numbers and variables only. So we have to then be able to come up with a system. So I can legitimately say that x plus y equals 18 and 5x plus 9y equals 122. And my goal is to solve for females, so I can eliminate males. So I would multiply the first expression by -9 because we want male values to go away. So -9x minus 9y equals a -162. And then we're going to add these expressions together. And so we get -4x equals -40. So x must be 10. So then if I plug it in for right-handed females, 5 times 10 is 50. Sorry, my little pen is not working great today. I don't know why. So here's 50 over 122. So 50 divided by 122 would give us 0.41 as our answer. So A would be our answer. Okay, so that's a more complicated version of that problem. So now, as we're moving along to some additional concepts, we're now going to move into the family of mean, median, mode, and range. And I'm going to leave standard deviation, which is another concept that we should be talking about as well, to a different slide. But let's start with the basics. So what I have here is definitions for each concept, and then we can practice a couple of the problems therein. Mean is a fancy word for average, and they'll say arithmetic mean to be even like more confusing. Every time I see that, I cross it out and I write down average, because I just don't want to be confused by some, more expensive vocabulary that could be confusing on the test. Median is the middle number in a set. If you're driving a car, I always think the median of the highway is in the middle of the road. So that's one good mnemonic to help us remember the median. Mode occurs most, so it's the most frequent data point. And range is the difference between the largest and the smallest number. Remember also that to find the median in the set, you have to line everything up accordingly to then find the median number. So you can't just go through a list if it's out of order. Like, for example, look at Jackson, Van Buren, Harrison, Tyler, Polk, Taylor. I couldn't just cross off the top and the bottom and assume I'm finding my median. I have to set up all of those numbers in order, and then I can be able to find my median. So you have to remember that trick. Here, our data set is already in order, so you can work your way out, knocking off the largest and the smallest number to find your way to the middle. The other way that I think about this as well is that if you have lots and lots and lots of data points, you can add those data points together and find out how often that data point happened, and then subtract from the top and the bottom. So, so we can take a look at that as well. Okay, so question number 12. Based on the histogram above, which is closest to the average number of seeds per apple? Okay, so we're gonna have to put the average together. So average number of seeds. So it's based on the number of apples and the number of seeds. So you have 2 apples with 3 seeds. So average number of seeds per apple. So when we're thinking about this, so we have 2 apples with 3 seeds. So I would say 3 plus 3, right? Because it's based on frequency to add them all up and divide by how many apples there are. Then I have 4 apples with 5 seeds. If it's easier to add them up for total seeds for those 4 apples, so you're adding up fewer data points, that can be easier as well. So 4 times 5 is 20. We have 1 apple with 6 seeds. We have 2 apples with 7 seeds. we have 3 apples with 9 seeds. So we can add them all up and then divide by the 12 apples, and then that will give us the average number of seeds per apple, which is 6.08. So it would be approximately 6 seeds per apple. Okay, here we're looking at the lengths of fish. So the table above lists the lengths to the nearest inch of a sample of 21 brown bullhead fish. The outlier measurement of 24 is an error. Of the mean, median, and range of the values listed, which will change the most if the 24-inch measurement is removed from the data? Well, if you think about it, the mean is the average. And so if you take 24 out, it would probably change by a few points, but I don't think it's going to change significantly because you have so many data points that you're pulling from. The average, you pull 1 or 2 data points out, it's not gonna change that bell curve very much. The median, I mean, given how many are here, I would think it's probably pretty close to 12. If it's not 12, it's 13, and if it's not 13, it may go the other way to 11. But I would think it's pretty close to 12. So that's not going to change a lot. But the range, I think, would change significantly, because if you did 24 minus 8, that's 16. And if you did 16 minus 8, that's 8. That's a big drop. And it's not going to change by the same amount because you're taking this data point out completely. So my answer for 14 would be C. Okay. So now here we have a survey taken of the values of a home in a county. And it was found that the mean or average home value was 165,000 and the median home value was 125,000. Which of the following situations could explain the difference between the mean and the median? Well, where I live, there are a lot of twins. We call them twin houses. They're side by side. There are also duplexes, lots of top and bottom, and fourplexes, which is like 2 top, 2 bottom. And then there's single family homes. And then there are condos. And then there are apartments. And it's pretty densely populated. So if all the apartments were, say, condos, they may sell for $50,000 to $100,000 a piece, and there's lots of them. But if you go to the single family homes, they're expensive. And so the difference in price of one single family home could really offset that median price of the typical home because there's so many of them. So let's come up with a hypothetical. Let's say we're only dealing with 3 houses in the whole town. So we have 2 that are 100,000, right? And we have 1 unknown, right? And if we divide it by 3 and we say that that is equal to, let's make them 125, just like the problem. My apologies. 125,000. Okay. And then let's say they're equal to the average. So this would be your median home price. And then we're trying to figure out what the expensive house would be. And we're going to set that equal to the average here. So 125 plus 125 is 250. And 165 times 3 is 495. So if I take 250,000 plus X equals 495,000, oops, my 4 is all wonky, 495,000 and the 5. And I subtract 250 from 495, that means that one house is worth 245,000, almost double what the other houses are worth. So if we look at the choices here, the homes have values that are close to each other. Well, not necessarily. This one's almost double. There are a few homes that are valued much less than the rest. Well, we don't know that. I mean, you could have multiple data points that are pretty similar. There are a few homes that are valued much more than the rest. True, that could totally be the case here. Many of the homes have values between 125 and 165. Well, if I added more houses into this and more unknowns, I could have one house that's worth $1 million, but the average comes down to 165 because there's a lot of houses that are worth significantly less than that. So there, I would say my answer is C. there are a few homes valued much more than the rest that are causing that average to be much higher. Okay, so I think you're getting a sense of mean, median, mode, and range here. So let's take a look at standard deviation. So standard deviation creates a bell curve. You can almost see it here in problem number 28. If you were to draw a line creating a like a upside down parabola, right, to create an upside down U, this one would have quite a spike over 72, and this would be like a low, slow U from 80 to 112. So standard deviation is how much the data ranges from the average. And that's all that that means. And so they're going to throw that in there and make it a little bit confusing. And really, it's not that hard of a concept. If you've taken psychology in school, or if you have if you've had economics, or if you've been in prop stat, you've definitely come across standard deviation. If you haven't done any of those things, not to worry. It's just these are the kinds of problems, and that's where the familiarity with standard deviation would come up. And that's all it is. So we're going to take a look at two problems that'll hopefully solidify in your mind the definition of standard deviation. So the tables below give the distribution of high temperatures in degrees Fahrenheit for city A and city B over the same 21 days in March. Okay, so what I'm going to do is actually create like a little T chart, or not a T chart, an XY chart of frequency and temperature, okay? So how often it occurs, and then we can create a bell curve there. So 80 degrees, highest temperature here, they had 3 data points, and 79 degrees, they had 14 data points. It seems very comfortable. That's about 14. 78, they had 2, 77, they had 1, 76, they had 1. Okay, this bell curve is going to be very tight to the temperature of 79 degrees. So it's going to be a very narrow. So it is what we call a low standard of deviation because it does not range very much from that average. Okay, let's take a look at city B. So we have 6 at 80 degrees. We have 3 at 79 degrees. We have 2 at 78. We have 4 at 77. And we have 6 at 76. So I would say that that bell curve is quite wide. We call that a high standard of deviation because the data points range much more widely in their frequency, how often they occur, between all the data that was presented. So which of the following is true about the data shown for these 21 days? The standard deviation of temperatures in A is larger. Nope, I would think that that's narrower. The standard deviation of temperatures in city B is larger. True. The standard deviation of the temperatures of A is the same as B. Nope. And the standard deviation of temperatures in these cities cannot be calculated. No, I think we can calculate it. I would go with B because the standard deviation, you have a much wider bell curve. Now, you can see that they actually already plotted those points for us, which is really nice here for question number 28. So the 22 students in a health class conducted an experiment in which they each recorded their pulse rates in beats per minute before and after completing a light exercise routine. The dot plots below display the results. Okay, so if I were to draw a line over this, this would be a lower standard deviation, and this would be a higher standard deviation. So the first one would be a lower standard deviation, and the second one will be a higher standard deviation. So they are not equal to each other. Let S1 and R1 be the standard deviation and range, respectively, of the data before exercise, and S2 and R2 be the standard deviation range, respectively, after exercise. So let's find range for S1 or R1. So R1 is going to be 88 minus 56, which is 32. And then R2 is going to be 112 minus 80, which is also 32. So our ranges are equal to each other. So we can get rid of any of the answers where they're saying that they're not equal. So you can get rid of B and C. And then, are the standard deviations the same or different? Well, I don't think that they're the same, so we can get rid of A. So your only plausible answer would be D. So that takes us through mean, median, mode, range, and standard deviation. And now we start to move into percentages. And so I just want to give you sort of a preview of some of the percentage problems that we're going to see. So we have percentages, and then we're going to move into exponential growth and decay, which is thinking instead of like percent change maybe one time, now we're actually thinking of something that occurred over a period of time and causes a parabola. So it's going to form a parabola. Okay, so here are a load of percent problems. You can see that I had a lot to choose from. I have lots of problems that I can present to you. Every test has a number of percent problems and asking you questions about percentages. So let's talk about number 13. So this may go back and touch on some ratios and proportions because they can be translated as percents. I may ask about a true percent change as well. So a group of 10th grade students responded to a survey that asked which math course they were currently enrolled in. The survey data were broken down as shown in the results above. Which of the following categories accounts for approximately 19% of all survey respondents? So it has to equal 19%. Now, here's something to think about. If it's females taking geometry, so that'd be 53, right? And it's of all survey respondents. This is 53 is to 310. So again, that's a ratio, 53 divided by 310. So that is 17% of students. Females taking algebra 2, that's 62 over 310, which is approximately 20% of all respondents. Males taking geometry, which would be 59 out of 310, which is 19%. Okay, so it seems like we're hitting the nail on the head here. Males take algebra 1, that would be 44 out of 310. And without even doing the math, we know that it's even lower than our lowest number here. So 44 out of 310 is 14%. So there, our answer would be C. Alma bought a laptop computer at a store that gave a 20% discount off of its original price. The total amount she paid the cashier was P dollars, including an 8% sales tax on the discounted price. Which of the following represents the original price of the computer in terms of P? All right, this leads me into a little side lesson about percent change and about thinking of numbers that work well for percent change, and also how to deal with that here in general in life about tax and tip and then discount rates and how to think about that. Okay, first of all, I'd like to pretend what her computer cost. And so I'm going to say her original price of her computer was $100. Okay, when we're talking about discount, a two-step way to answer this would be to multiply by 0.2, which is $20, but then you have to go to your next step, which is 100 minus 20, which means that she would pay $80 with the discount. Instead of doing that, instead of like jumping into a two-step problem, I like to think in the one-step way, which is if the computer was $100 and she had to figure out what she had to pay for the computer, she's actually paying 80% of the price. Because do that step in your head first or write it out if you need to, but think about what remains for the payment, not what you're taking away, because it's forcing you into two steps. And a lot of the answer choices will be written with a one-step rule. So that means she's left to pay $80, okay? And see how that's one step, I didn't have to subtract 20. Also, the total amount she paid was P dollars, including an 8% sales tax. Okay, so again, we can do this two-step. We can do 100 times 0.08. So 100 times 0.08 is $8, right? And then we can add that to, oh, wait. Sorry, it's on the discounted price. Let me do that again. I thought something seemed funny. Okay, so it's on the discounted price. So she's paying $80, which we've now assumed here. So $80 times 0.08 is $6.40. So now if I have to add that to $80, that means that she's going to pay $86.40 for this price. I don't know what is up with this thing today. There is my really sad 80. Okay, it's looking like a toddler is writing. Okay, so 86.40. Now, a one-step way to think about this would be to take the discounted price for the computer and multiply by 1.08. Here's why. She is agreeing to pay 100% of the discounted price. That's where the 1 comes from, but is paying an additional 8% in sales tax. And if everybody takes their calculator and takes 80 times 1.08, you can see it automatically adds in the sales tax to this price, which would be $86.40. So I like this knowledge of substitution. I like thinking in real terms. I don't like thinking in terms of variables. It makes it a lot easier to reason. So that means that what is her P price? It's $86.40, okay? That is her new price with the discounted computer and adding the tax in. So which of the following represents the original price of the computer in terms of P? Okay, so using this information, our goal is to try to get back to the original price. So we can calculate all the answers. 0.88 times 86.4 is $76.03. That's not $100. If I did 86.4 divided by 0.88, that's $98.18. Again, not $100. If I did 0.8 times 1.08 times 86.4, that's $74.65. So D, 86.4 divided by parentheses 0.8 times 1.08 end parentheses, that gets me back to $100. So I think using real numbers for percents, particularly the number 100, because you can see percent change immediately in real numbers, makes it a lot easier to be able to answer some of these percent problems. I'm going to stop here for a second because I presented you with a new perhaps a new concept, maybe something your math teachers have taught you already, but just thinking in a one-step way instead of a two-step way, because we're going to use that for exponential growth and decay in a moment. Any questions about this? Would anybody like me to do another example without even what we have here on the screen? Okay. So now let's look at 26, because that one really talks about this percent change of adding. So Katerina is a botanist studying the production of pears by 2 types of pear trees. She noticed that type A trees produce 20% more pears than type B trees. So if B produced X, A produced 100 plus 20%, which is noted as 1.2. So when we're dealing with decimals, you move the decimal 2 places to the left. So it'd be 100 plus 20, which is 120%, or 1.2. And type A trees produced 144 pears. How many pears did type B trees produce? I would do 144 divided by 1.2, which would be 120 pears. You'll also notice this is question number 26 out of 30. This is a harder problem because we have to think about this 100 plus the 20%. Okay. We're going to do questions 4 and 5 together because we actually have to do a takeaway like we did before. And they're supposed to be on the easier side, but I can tell you that the majority of my math students miss question number 5. Like to the tune of 85% of students who take this particular test in succession miss this problem. And it's supposed to be on the easier side. So having this concept of percent change is really important. The amount of money a performer earns is directly proportional to the number of people attending the performance. The performer earns $120 at a performance where 8 people attend. So if you have 8 people, you earn $120. Okay, awesome. How much money will the performer earn when 20 people attend? Okay, so guess what? This one's a proportion. 8 people is to 120, as 20 is to X, cross multiply and divide, which would be $300. Okay, so that's the answer for number 4. Number 5, the performer uses 43% of the money earned to pay the costs involved in putting on each performance. The rest of the money earned is the performer's profit. What is the profit the performer makes at a performance where 8 people attend? So here's what happens. 120 times 0.43, which is the first number that everybody sees. Oops. Which would be $51.60. And bam, there's my answer. And everybody forgets to do the second step, which is what I warned everybody about. And they forget to subtract 51.60 from that number so they can see how much money they have left, which is $68.40. So if you follow my method, which is how much money is left in our pocket, what percent is left, we would do 120 times 57%. So 120 times 0.57, which is $68.40. And it takes us there in one step. So look for what is left of the value, not what you're taking away. If we're adding tip or tax, it's going to be more than 1. It's going to be 1 plus the number. Okay. So I'm shifting out of percent change for a moment because there's lots of other problems that you can practice. And of course, I'm going to send along the answer key later. So then that way you can see if your answers match up. And if you have any questions, you'll let me know next week. But I'd like to move into exponential growth and decay. So the formula for growth and decay, trying to write it on a PowerPoint is kind of hard. So what I'm going to do is write it here. So you have your outcome value is equal to your original value times 100 plus or minus the percent raised to time. So if you have growth, that is going to be 100 plus the percent. So it'd be 100 plus the percent. If you have decay, that is going to be 100 minus the percent. It's going to be what remains of the value. And that's important to see. So let's take a look here. So a radioactive substance decays at an annual rate of 13%. If the initial amount of the substance was 325 grams, which of the following functions models the remaining amount of the substance in grams 2 years later? So your original amount goes here, 325. And remember, it's decay. So it's going to be 100 minus 13 raised to time. So you wouldn't pick an answer with 0.13 in it. It's going to be what's left after 100 minus 13, which would be 0.87 raised to time times 325. So that is what your decay function would look like. Here's another example. Now we're going to flip to growth. One of the following 4 types of savings account plans, which option would yield exponential growth? So growth is going to be a function that takes off at an initial amount and then exponentially grows. Decay is going to be a number that starts at a certain number and then decays at a particular rate. So exponential growth would not be a constant. Exponential growth would be compounding on itself by a certain percent. So each successive year, 2% of initial savings is added to the value of the account. That's going back to the original amount. So let's do 100. So 2% of 100, I'm going to add $2 every year. That's not exponential. Each successive year, 1.5 of initial savings and $100 is added to the value of the account. So again, 1.5 of 100 would be $1.50 plus 100 would be $101.50 is added to the account every single year. Again, that is a constant. That is not growing at an exponential rate. Each successive year, 1% of current value, haha. So if you start at 100 and then you go to 1,000, then you go to 10,000, then you go to 100,000, 1% of that grows exponentially. And each successive year, $100 is added to the account? No way, Jose. So C is our answer for number 21. Okay. All right, here we go. In planning maintenance for a city's infrastructure, a civil engineer estimates that starting from the present, the population of the city will decrease by 10% every 20 years. So this is where exponential growth and decay get a little tricky. Okay, so what happens, again, we have our original value times 100 minus the percent, right? And it's raised to time. But you'll notice here, the time has been chopped into pieces. It's every 20 years, it's not every year. So it's going to be years out of 20. So it's not 20 times the number of years, it's years out of 20. If they said it's out of months, it would be months out of 12. If they said it was hours in a day, it would be hours out of 24. If they said minutes in an hour, it would be M out of 60. You get the point. So if they're going to chop something up in increments of time, then your exponent turns into a fraction. So if our original value is 50,000 for the population and they're losing 10% a year, that means they're left to have 90% of the population because they're just losing 10%. They don't have 10% left. They have 90% left. And then that is going to be in a decay rate out of 20 years. So D would be our best answer. So these are the kinds of exponential growth and decay questions that we'll see coming up. And there's a couple more there for you. The next would be survey questions. And these are kind of funny because survey questions are inherently flawed. Let's talk about, did I find the one? Oh, I didn't find the one. I was thinking of it, but okay. Number 7, the members of a city council wanted to assess the opinions of all city residents about converting an open field into a dog park. Sounds great. We have a ginormous dog. The council surveyed a sample of 500 city residents who own dogs. The survey showed that the majority of those sampled were in favor of a dog park. Of course they were. They own dogs. Which of the following is true about the city council surveyed? It's flawed. They only asked people who own dogs. You have to survey a good sample of people who own dogs and people who don't own dogs. And there are surveys out there about, we'd like to build a playground. So we surveyed people who were who were elementary school kids. Like, of course they want a playground, you know? So that's the thing. A lot of these survey questions are going to be inherently flawed. So you have to look out for the flaw. So A, it shows that the majority of city residents are in favor of the dog park. No, because they didn't survey the majority. The survey sample should have included more residents who are dog owners. They already did. The survey sample should have consisted entirely of residents who do not own dogs. No. Or the survey sample is biased because it is not representative of all city residents. Yes, that's the bias. So D. So we have to be careful with that. Look at number 13 here. A researcher conducted a survey to determine whether people in a certain large town prefer watching sports on television to attending the sporting event. The researcher asked 117 people who visited a local restaurant on a Saturday, and 7 people refused to respond. Which of the following factors makes it least likely that a reliable conclusion can be drawn about the sports watching preferences of all the people in the town? The sample size is fine. If you have more than 100 people, you're getting representative opinion. You're okay. Population, we don't know the population size, and that doesn't matter. They said large town, more than 100 people surveyed, you're good. The number of people who refused to respond. I mean, if 7 people didn't want to respond and you have 110 surveys total, I think that's pretty good. My problem is D. If I am in one restaurant, what if I'm at a fine dining restaurant? They do not have televisions. What if I'm at a sports bar where everybody's there to see the sports games? I think you're going to have a flawed opinion based on where the survey is given. If you're standing outside of a grocery store and you had more of a representative population, that would be a more accurate survey. If you had a census or survey door to door of, 25% of the people in the town, then you'd have a more accurate sample. So a lot of times with survey questions, you have to watch out. They're flawed. Okay, and my last slide for the day, talking about word problems using percents. So of course I didn't like that. And if I take the S off, it's like percent, but percent's more than one. Anyway, okay. So here, what we want to do, I mentioned distance equals rate times time. We're going to use a similar idea here for questions 37 and 38 because it's using a similar formula to that. So let's start off with number 37. So if shoppers enter a store at an average rate of R shoppers per minute and each stays in the store for an average rate of T minutes, the average number of shoppers in the store N at any one given time is N equals R times T. This relationship is known as Little's law. So N equals R times T. So T is time. R is the number of shoppers per minute. And then this is average shoppers. I personally like to label new formulas when they give things to me, especially when they're making some association, just so I understand how it works. The owner of the Good Deal store estimates that during business hours, an average of 3 shoppers per minute, so it'd be 3 shoppers per minute, enter the store and that each of them stays an average of 15 minutes. So it would be 3 times 15, which would yield 45 shoppers. The owners uses Little law to determine that there are 45 shoppers in the store at any time. Okay. Little's law can be applied to any part of the store, such as a particular department or the checkout lines. The store owners determined that during business hours, approximately 84 shoppers per hour make a purchase, so 84 per hour. So first of all, this is per minute. So we're going back to unit conversion. We have to think about that. So 84 divided by 60, you need to figure out the number of shoppers per minute. So 84 divided by 60 is 1.4 shoppers per minute, okay? And they spend an average of 5 minutes in the checkout line. So 1.4 times 5 means that you're going to have 7 shoppers. So at any time during business hours, about how many shoppers on average are waiting in the checkout line, it would be 7. So it's that unit conversion that we had to do in the beginning that's really important for us. So you can notice that this is a little like distance equals rate times time. It's the same kind of concept that they're trying to apply here. Okay, so we're about to use this original formula because they're going to mention it here, and then we're going to come up with new information. Okay, so the owner of Good Deal store opens a new store across town. For the new store, the owner estimates that during business hours, an average of 90 shoppers per hour. So 90 divided by 60. So 90 divided by 60 is going to be 1.5. So again, we had to convert 90 per hour. And they stay for an average of 12 minutes. So times 12 is 18. Okay, now, the average number of shoppers in the new store at any time is what % less than the average number of shoppers in the original store? So the original number of shoppers in the store is 45. So I mentioned this earlier today, when we're doing percent change, it's the difference divided by the original. So it'd be 45 minus 18, so 45 minus 18, which is 27, and then that number divided by the original number, because it's what is the difference in shoppers divided by the original. So 27 divided by 45 means that it was a 60% change between them. So that would be it. So that takes me through percents. So you can see that I'm going back and using systems of equations at times for these problems. I'm using unit conversion. I'm going to use ratios and proportions. And there are lots and lots of word problems. I'm also organizing it as I'm reading it a little at a time. These are all the big sort of connecting concepts that are going to bring everything together. And I just want to leave it open for anybody who may have questions at this point, for me to see if anyone had anything that was confusing or problems from last week that you'd like me to review that maybe you had trouble with, and any particular topics there. So that'll conclude our day today. And just one more plug for tonight. Peggy sent out, or will send out an invite to you. You're welcome. Well, this afternoon, I should say for you, but tonight for me, to join me at 3:30 to go through all of the next steps in testing and test optional, and how many more schools are going test optional, and sort of what do these announcements mean, and what does that mean for you practically as a timeline? Like, when do you actually start diving in realistically for test prep over the summer months?
Well, that sounds great. I will send that out right now. And it's 3:30 today, right?
3:30 today
Okay.
till 4:45. If it goes that long, it may. There may be
Okay.
lots of questions. There may be people who are like, okay, thanks.
Well, this was wonderful.
Great.
This was great. It was interesting. It was great to listen along. So I hope these folks all got a lot out of it. I want to say I have hard copies of tests 7 and 8 and answer keys for them. So I probably will at some point send them out to kids, and we could do like a, so they don't have to kill any more trees to do them. Which one of those is the ones with the answer key? Either of those, 7 or 8?
Coming from me?
Yeah.
I think I sent the answer key for both, and if you don't have it, I can send them
No,
over.
I don't mean the answer key. I mean the one that was explained, or is that what you mean? Those are the ones.
The problems today?
Yeah.
The problems today, so last week the problems came from test 1, 2, 3, and 4 exclusively.
Okay.
The problems from today were from 1, 2, 3, 4, 5, 6, 7, 8.
Okay. Because I have a sense that for at least for juniors, one thing that maybe is going to be important is that they do a pre-test of the ACT and the SAT, so they know which one's better, in case with all of this craziness they only get to take one. Does that make sense?
Yeah, I agree. And what I'm going to do is offer proctored timed tests.
Oh yeah?
Regular time tests. I'm going to offer a proctored time test on, I just want to make sure I'm getting the dates right. Regular time SAT on June 15th. Extended time SAT June 16th, but only 50% extended time.
Okay.
Regular time ACT on June 17th. Extended time ACT on June 18th.
Okay.
And of course then, we can grade it thereafter, but it'll be a virtual test. I will send them the test ahead of time, that they can then print out to have it in pen and paper form, and then they can have me in the window as a proctor during that time.
So maybe you all want to write those dates down tentatively on your calendars. And extended time means that you've got an accommodation for your testing, so you've been given extra time.
So you have a
But maybe,
504 IEP or
yeah.
something that's implemented at your
So
school.
maybe write those dates down, just so you're in a position to do that. Yeah, that's great.
Yeah,
Uh,
so I would start at 9 a.m. on those dates, 15th, 16th, 17th,
oh,
18th.
so that's early for us.
Oh, geez.
Yeah.
Okay.
Well, there are other people doing them, I think. I don't know if anybody's
Yeah, I
doing it
forgot
yet.
it's your time zone thing. Okay.
Yeah. Don't
Yeah.
worry about us. You got to, I mean, yeah, no worries. We can figure that out.
Yeah. So
Unless
I
people
know
want to
that
get up.
I know that Compass does them as well
Yeah.
for free.
Yeah. And
So
I saw
that's another
another,
option.
I think Apple Routh or something is doing at the end of, I'm not sure when, but I'll keep you all posted on when those opportunities are. So,
Yeah. So
okay.
and if you want me to run one because I can start a secondary one at noon my time, 9 a.m. your time,
Okay.
just so it's close enough to your what the start time would be.
Right.
In
That's a big difference.
it makes a big difference because if you're taking a test at noon your time, that's way different than if you have to wake up and be at the school at 7:45 in
Yeah.
the morning
Yeah.
and do all those things.
Okay. So that'll be something coming. And then what's next week is geometry, huh?
Next week is geometry, length of an arc, area of the sector, and all of the like harder problem types that I can present, unit, circle, SOHCAHTOA, all that fun stuff.
Cool. And if you all have questions that you were shy to ask, you can email them to me or you can send them to Lynn after this. So we'll make sure they get out there.
Perfect.
Okay. Thanks, everybody.
Have a great day. I'll see you next week.
Okay. Thank you, Lynn. Bye.
Welcome. Bye.
Bye.
You. Bye.
Thank you. Bye.
Thank you.
Thank you.
Thank you.